Hey, good. How are you?
Want to say anything about the convention in the Southeast? I don't look at much.
I want to know that.
Yeah, it looks like there's going to be MCS forming that convention down there today.
Do you want to say something today? Yeah, that'd be great.
Yeah, sure.
Excellent.
Again, I don't think I.
Did somebody talk to you about coming to the users meeting?
Yeah.
Are we coming?
Yes.
Good. That's what happened. Okay. Okay. I know your name was 30 and among a bunch of others came up.
So, yeah, I think there's still concern on what we do. Maybe it depends on tutorial versus talk versus other options.
I think those are the either you can talk or you can talk and lead sort of a group. So
Right. So yeah, I have an email from Kevin and say, hey,
I gotta talk to Tim Schmidt about those things and find out if there's anybody in the building actually doing science with the data yet, rather than just pretty pictures, because that was one of the things that came up too. Was it'd be cool to see what sort of scientific stuff is coming out of it so far.
Right. That's the one that they shoot, right? It's like 25th through 27th.
Yeah, it's 25th through 28th. It's like the whole workshop. It's like from Monday morning through Thursday afternoon. So,
What's it about? What's the theme?
what is it? Reducing the time from data to science, I think is the theme. And there's a day on data processing. Analysis, there's a day on GOES 16, there's a day on ensemble modeling, there's some focus on like machine learning kind of stuff. There might be some of that to do with those. I mean, it all kind of
doing that somewhere.
Ryan's doing part of it. We're still in the early stages of getting people to come. And once we know who is all coming, then should hopefully, and the idea is to kind of have a keynote each morning and then a couple of the activities during the day. Maybe a panel at the end of the day to sort of finish it out.
Oh, we already passed it, right?
We're ready to go.
Okay.
Yep.
We'll leave this on the side and do a regular super peak review.
Yeah.
Okay. Welcome to our weather discussion. First one for me in 3 weeks. I took off on the 23rd. Wasn't here.
Same here.
Maybe we didn't have one, I can't remember now. But anyway, we're back. And with 4 weeks to go. So we'll end on the 4th of May unless the weather gets exciting on any subsequent week. We sometimes convene. But when we do in the spring and summer, I don't know anything about the weather. So anyway, this is kind of the end of the line for me, winter time. But let's start with our, what a winter it's been. Let's start with our satellite movie frequency. So by the time we get here at noontime, we actually get to look at the visible. I don't have to pick up something at 9 o'clock. It's infrared. So it's kind of nice to see the visible. Sometimes different features show up that are a little more obvious in the visible. I think one of those is this cluster of convective clouds, which is, we're on the western fringe of that. And it's probably going to, well, we might even see it in the radar. I think it's dropping precipitation. It may not be getting to the ground. We have a big dew point depression. It's like 16 degrees or something right now at the surface. So the air is pretty dry. But I think this is all convective snow showers, most likely. It's very cold, persistently cold, and I think you'll see in the forecast it's going to stay cold for, what's the day, the 6th? Right through the 20th or so, maybe even longer than that. So 2 more weeks, just amazing. Friday the 13th may be the only day where it's not quite that bad, but it'll be thundery, so it'll be pretty exciting on other squall. And you can see there are not really so many well-developed features, evident anyway on this map, today, as we've seen in other more recent ones during the month of March. We saw a series of cyclones on various Fridays going along the East Coast. Today, it's mostly cloud elements that are streaking across the country from west to east. Hidden underneath all of this, or hidden because there's no particular structure to it in terms of cloud mass, is a really intense upper level front that we're going to look at from a variety of perspectives. That's now over the eastern part of Montana, into South Dakota and maybe make its way to Iowa. I contend, although I don't know if this is true, this would be at least it's a research idea that one could pursue, that the very sharp edge to the clouds here, noticeable not only on the visible satellite image from South Dakota all the way across Iowa, but we'll see it also on the radar, may just be evidence of there being some subsidence and some sort of downward vertical motions in association with the development of the upper front, lapping right up against the cloud elements that are over the state of Nebraska and parts of Iowa. So that's interesting in and of itself. Jessica Taheri, one of our graduate students who's been interested in atmospheric rivers for her entire career here, is currently, I think, in San Francisco or somewhere near it, about to be hit by one of these features for the first time in her life. So that's exciting for her, and we'll talk a little bit about that, both in the current ops and perhaps in the forecast. And then there's some convective weather across parts of Arkansas, northern Mississippi, parts of Alabama, and heading into Tennessee. So this looks pretty interesting as well. See, it looks even more interesting on the radar. But as I say, my eye to this says there's not really anything particularly well organized, this cyclonic disturbances across the continental states today. And that's a bit of a difference from what we've seen for much of the prior month. So let's take a look at the radar that goes along with this, Pete, and then we'll go to the West Coast satellite. Yeah, so looking on the radar, isn't it interesting how sharp this boundary is? And it goes all the way across just south of Chicago, or actually south side of Chicago. It's got precipitation falling into the sky, the north side doesn't. But it's really a sharp, continuous line. I think there's some connection there maybe to what's going on at levels above that. I don't know if that's right. But then you've got this broad region of convective showers, open water, cold temperatures. We'll see the temperatures are about -30 or colder at 500 millibars. And the water has got to be at least 5, you'd think, or 0, somewhere between 0 and 5. And so you got a pretty steep lapse rate there, and that's enough. And there's cyclonic flow broadly in the region. And then here's heavy precipitation in Northern California and the northern part of the valley that is part of this atmospheric river that we'll see a little bit more evidence for on the satellite on the West Coast. And Jim Steenberg was writing today about a really warm, rainy event in Salt Lake City. So way above normal precipitable water values and way above normal temperatures for this time of year. So a combination of really unusual conditions in and around the Salt Lake. That's probably bad. He's a big ski aficionado. He doesn't like to see the Wasatch Range lose its snow, but that might be happening here to an extent that displeases him. And then there's snow across eastern and western New York State earlier today, western New York State, but now across eastern New York State. Some light snow falling across parts of Connecticut, Rhode Island, and Massachusetts as well. So, you know, it's just been a seemingly endless winter for them, starting pretty much March 1st, but it's not really abated since then. And then here you can see the distinct difference between the reflectivity that's always fuzzy when there's snow involved and very much sharper when there's just melted hailstones coated with water involved in the convective activity over Arkansas and Mississippi. So that's a pretty interesting situation down there. Okay, let's take a look at our West Coast satellite image, if we could, Pete. And we'll start with the infrared, but then we might go to the water bank. Let's try the infrared first. So here's the infrared satellite image. Pretty nice cyclone in the Gulf of Alaska, and some cloud element right along this southwesterly flow, developing at a bit of an inflection point, right in the ridginess of that stream from the subtropics. But there's Hawaii. So this is definitely a subtropical stream of clouds, undoubtedly connected to a subtropical stream of moisture, and it's making landfall in Northern California. And right now they're having pretty decent rains in Northern California, and I suspect that will continue for much of the weekend. A monster cyclone, probably deeply occluded, although difficult to say from this perspective because it's right on the edge of our viewing angle here. But that's a pretty deep storm right at about the date line. So that's the first really good-looking Pacific storm we've seen in some time in terms of big cyclonic disturbance. But we want to see, when we go to higher levels, a couple of things. Number one, it looks like there's probably a little patchy upper trough here. There's this local spot of what looks like cold air aloft, and that's right where the cloud development's going on downstream. So there's probably some development going on right at about this location, so halfway between between Charlotte and Hawaii. And I think there's also a very strong jet, more or less zonally oriented along, or maybe slightly forward deflected across the Pacific. And that might also be characteristic of these really intense atmospheric rivers. However, I'll say this, as far as I know, most of the studies on these things, and they become quite prolific, and I have one under review right now, as a matter of fact, that I'm reviewing this weekend. Most of them talk about individual events, which is excellent because then you get a nice characterization of what they're like. I don't know if we have very many studies that look at T-5, T-4, T-3 days of the sort of composite atmospheric river event that makes landfall in California. It'd be nice to know what the large-scale evolution of the basin is that leads to one of these features. And also, a la Zach Handlos, how frequently do elements of the composite actually show up in the individual cases? And there's ways to do that, which you might want to pursue. So anyway, I'll leave it at that for now. Let's start our tour of the super beats. Oh yeah,
Just a question. So would you, I mean, looking at this image, just this satellite image.
Yeah.
Maybe, I don't know, if you can't look at a water vapor 2 feet.
Oh yeah, I wanted to do that anyway.
Yeah, I'm just curious, you'll get a sense of it's not obvious. Obviously, I can see water vapor, it's going to be visible, but I mean, this probably gives you a better sense of a train of moisture that's emanating from the southwest of Hawaii, moving northeastward. But the other image wouldn't have been obvious to me. Atmospheric river.
Yeah, no, I agree with that. I agree with that. And I think for me anyway, I'll speak just for myself. Maybe you share some of this. For me, that comes from that sort of sense of I don't really know what I'm looking at. Comes from I don't really know what I'm looking at. I don't know how these things evolve. What are some of the characteristic features associated with them? When I see this satellite image and I imagine this dark spot being really a low tropopause, and then there's a wind speed maximum, most likely right along the warm edge of that, or the high water vapor edge of that. That lends some sense to me, better than the other infrared image did, that there's really a train of high velocity and forward directed flow from the subtropics.
Can I
A little bit
jump in
easier
a
to
little
see.
bit about
Yeah.
what I've been seeing happening with these? This entire event right here, this whole thing, is a tropical plume. And at the end up here, you got,
You speak up, sir.
this whole thing is a tropical plume coming up like this. And at the end, you have some gravity waves and strophification that occurs up there and all that stuff up there. But this entire tropical plume, what it is, it's actually this region of very cold air in the tropics at high levels moving up, and it creates high pressure underneath. And so there's high pressure at the ground, and what you get is an anticyclonic circulation. You can kind of see within this. What that does is it creates a phonogenesis process along its western side, which takes moisture field from the tropics and concentrates it into a band, which comes up the western side of the plume. And that's where these plumes are coming from.
Okay. And what's the depth of the water vapor stream?
Well,
Does it assemble? It assembles through a deeper column than normal, probably.
Yes, it's basically the stream of water vapor from close to the ITCZ or wherever that plume is anchored.
Yeah.
It takes that there, and I would say the moisture goes up to about 500 millibars.
Okay.
Or more.
Okay.
So it's pretty deep. It's not just a surface boundary layer.
Yeah.
And but the thing about the tropical plume is that the phonogenesis process, deformation fields on the western side are what create that band.
Yeah, that's really sensible, and then it's tied also probably to a wind speed maxima on the top of it, which I think you can see
Yeah, well, the wind
sometimes
speed
on the.
maximum, yeah.
Yeah, right.
Jet
where
stream
it
is there,
is. Yeah.
because the jet stream, actually the jet stream bounds the whole
Yeah.
plume.
Yeah.
But yeah, certainly there's a jet stream aloft, but it really has to do with this high pressure at the surface and the anticyclonic flow that's responding to being in that plume. The plume itself is a tendency for that upper level part of the Hadley circulation to plume out to the poles and create an Elias and palm flux of heat and momentum toward the poles. And so this is one of those Elias and palm fluxes. But the surface reflection of that is this phonogenesis process. And you see these all over the world at any given time.
But not everywhere. There are preferred locations for these things.
Yeah, the preferred location.
And the storm tracks, sort of,
right.
So I see this thing developing sort of right off the coast of Oregon, that little comma cloud is developing.
Right.
Is that evidence that you've got an intrusion from high latitudes that's assisting in the production of this train?
Oh, no, I doubt that has anything.
No, not
one
that one, but
south of it.
the one south of it. Yeah.
Yeah,
Right here?
No,
Yeah.
that cloud head right there. Or is that something developing in situ along a subtropical jet?
I think you're some kind of a barotropic instability in a subtropical jet.
Okay.
That's what I would guess.
It looks like it's just what John had described earlier is just looks like there's an upper trough that's
Yeah,
happen, I mean, I think they're two separate features. I don't know if they're
Yeah, well, that's-
directly linked.
I think the fact that the air is racing along in the subtropical jet right here probably has something to.
see, the reason I ask, Greg, is because I know that your theory about explosions poleward has an episodic aspect to it. They're episodic. But I'm wondering if there's also an episodic pulsing based on the assistance from the intrusion to fairly low level of extratropical disturbances. So that you have maybe two reasons why these things are episodic.
Yeah, they work together.
Yeah.
Get stuff over the top of stuff.
Yeah. But they can work independent, but sometimes they can work together.
But this would be extremely strong if this plume would come up like this. I think that thing would go up into a super bomb.
Yeah.
But it's not what the plume's doing.
Yeah.
So. Yeah.
Yeah, I'm interested. That's really good. Thanks. And I know people like Ben Moore and some others are looking at these integrated vapor transport, right? And one of the things that's interesting about what you just said from that perspective is if you've got this kind of concerted effort going on in the whole lower troposphere, maybe up to 500 millimeters, how much of that integrated vapor transport, the anomalous integrated vapor transport, is anomalous only from 700 millimeters high? You know what I mean? So you're really getting deep structure of water vapor transport. And that's what characterizes the river versus just the average southwesterly flow ahead of an upper trough at 35 degrees north. Because they happen in the wintertime all the time.
But getting to the depth of that, Greg, we got into this discussion before Weather Watch. I was looking at that, knowing that there's going to be this atmospheric river, and did a quick cross section. And I was kind of surprised, at least for the one that I did. I didn't do multiple ones. It seemed like a lot of the water vapor was in the even below 500 in terms of the. So again, it wasn't integrated; it was just a cross section.
I think they're intriguing structures, and maybe I'm wrong, but it seems to me that something about a composite structure of these things and an evolution in a composite is really worthwhile to undertake, to understand the broad characteristic structure, flow environments that would lead to them.
I think being on that edge, on the forward edge there, and being in that confluence or convergence field at the surface is going to push the moisture deeper.
Yeah, and so it should show up if you do one of these integrations, things like Ben does. And you could partition it in the vertical and say how, maybe it would be a way to distinguish between degrees of intensity of these rivers, would just be how much of the water vapor transport is going on above 600 millimeters.
So I like the idea of the compositing, but I guess the question would be, do you composite on where the maximum anomalous water vapor transport is in terms of vertical? Do you composite on the edge of the plume? Do it in theta? Do you do it in isotropic space?
I don't know yet. I would think isotropic would be my instinct, but I don't know. It'd be a good set of questions to entertain, though.
When you look at these plumes, there's certainly almost a jet of flow at low levels on the western side.
Yeah.
That's pretty typical near the surface. And then there's northerly flow on the eastern side, as you can see right there.
Yeah.
The other way.
Strong northerly flow, right? Yeah.
So there's a complete circulation in the plume.
Yeah, so anyway, this is going to be a big event. It looks like it'll probably make the national news. We'll hear something about it this weekend, I suspect. We were next going to go to the tour of the super peaks, I think, right? Let's start I guess we'll start at 500 millimeters because that's where we'll end up at another time. This is 12Z this morning. And I just want to point out, remember we saw that convective activity over the sort of northern lakes, western lakes anyway. It's minus 42 in the analysis, right near Isle Royale. And it's minus 41 at International Falls, minus 41 further upstream, minus 33 it looks like at Green Bay, minus 38 in the northern part of the lower peninsula. So this is really cold air. It doesn't actually get very much colder at 500 millimeters any time of year at our latitude. Maybe you get as cold as minus 45 or something, but this is downright cold. And so anyway, that might have something to do with the convective nature of the clouds that's around us now. Even if the water temperature is newly melted, it's plus 1 degree C, you got a 40 degree temperature drop over just 5 kilometers. So that's conditionally unstable. So there's plenty of reason to expect some of that convection is happening free. And there's a really intense baroclinic zone on the western side of this thing. Looked even better at 0Z, and I want to examine this a little bit in BIS 5D in a few minutes. But look at these wind speeds, 135 knots at Minneapolis at 500 millimeters, a couple of other 100-knot winds. And then these winds in the along isotrope direction are effectively zero. So you've got extraordinary horizontal shear right along this baroclinic zone. And there's geostrophic cold air advection in that cyclonic shear. And you can convince yourself readily that translates to negative vorticity advection by the thermal wind in this location. So the strong subsidence, is my guess, going on right in this, especially on the warm side of this upper baroclinic zone. That nearly coincides with that long, sharp edge of the cloud band and in the radar field, the reflectivity that we saw right about like that in the satellite. So there's something interesting about the presence of this upper level jet front structure and the northern bound of that precipitation band and cloud band. It's quite interesting. And this wave is not of zero consequence. This is a pretty sharp wave. There's a lot of sharp curvature right there. There's even a thermal inflection field that's a little bit out of phase, sort of a perfect situation for the development of this upper trough. So I'll be interested to see what happens with that feature in the forecast. But it's part of it's one little element of a broad, deep, cold upper trough that's sitting over eastern North America and is just pummeling us with one cold air outbreak after another at the late part of the season. And it's been cold forever in these several states of the Union for really several weeks in a row with very little relief. And strong northerly flow at 500 millibars all the way to the pole is back behind this baroclinic zone, although the thermal contrast is considerably weaker, but that's only because you're so desperately cold right in here. You can't get colder than that. And you get a little bit of warm advection and northerly flow over the archipelago. It's so incredibly cold on the western edge of this broad upper trough. So it's really interesting early April structure. And we had several snowouts. The Mets and the Yankees were both snowed out. We had some snow falling in Pittsburgh the other day during a ball game, and the same, I think, in parts of, maybe not in Ohio, but I think they had some snow in Philly and they had some snow in Pittsburgh during the game. I don't think that's happened at National Stadium in Washington. It might this weekend.
Right.
And we will be under the dome on Sunday, my son and I, at Villa Park, so we don't have to worry about it, but it'll be snowing on Sunday. So, pretty cool.
The other thing to point out is in the Pacific, you can see that upper trough.
Yeah.
That's approaching the, I think that was where the cloud head.
That's right. That's where the cloud head was. We saw the little patch of convective activity, and the temperatures here are, let's see, I want to just make sure I get the temperature right. This is minus 20 isotherm, minus 25. Warmer water here than right along the coast, but not by much. So, yeah, some convective activity certainly aided, and the cloud head aided by flow downstream of that fairly sharp curvature feature. And then we had the plume coming in around on that sort of orientation. So that's on the anticyclonic shear side of at least the 500 millibar jet. A really nice picture of that. And that's the difluent jet exit. So a lot of things going on here that are interesting. Let's take a look at 300 for the fun of it before we go to this 5D. So at 300 millibars, this is a really sharp jet stream. It's 162 knots across from Green Bay to the thumb of Michigan is the maximum in the wind speed. And it's a fairly nicely contained jet, especially in its entrance region. Well, I shouldn't say it's kind of a broad entrance region, but there is a sharp contrast of wind speed along the flow there. Here's the feature at 300 millibars off the west coast. One can see the turn to the north that we saw in the satellite, northerly flow, I should say. Straight flow across on the northern edge of the subtropical plume, but on the southern edge of the invading upper level extratropical trough. So there's some combination of these things working in this particular case, it seems to me. This is a strong circulation, thermally indirect, however, so the subsidence would be occurring there. Maybe trapping the water vapor at lower elevation. I don't know if that's good or bad. Maybe it's good. Kind of concentrates it in the vertical as well. Let's take a look at a little bit higher. Let's go to 200 millibars, see where these features lie at that elevation. You see a weakening of the polar feature across us. It's only 121 knots. Suddenly the emergence of a feature at, maybe we've gone too high even, this is probably not the jet core, but there's some subtropical feature across Florida and then toward Bermuda and up into the North Atlantic. And then clearly the jet off the west coast is a combination of subtropical and polar, because this polar piece seems the same, the subtropical piece looks more intense on the downstream side of the anticyclonic curvature maximum right along the coast. Very interesting
You go
structure.
higher than that?
Yeah, we can go to 100 is the next high, or we get 150.
150 is on there.
So there's 150, where everything's weakening, so we're past the jet core and all of them. And then the polar jet disappears entirely. There's almost nothing left of the
Well,
polar
that's a really classic polar jet.
Yeah, and this one over us is.
That's obviously
Oh,
a
this one.
subtropical jet over us.
Yeah, we got this 5D. I want to take a look at that. I didn't think about it, but we'll take a look through this jet off the coast. I bet you there's some really interesting structure in that, because it's not clear to me that there's a clear
That's
separation.
a western boundary.
Yeah, right, that's right.
Left to right.
But it's also got a really nice upper trough at 500.
Yeah, there's some
Okay,
You know, it's gonna, its circulation as it gets that far forward, is gonna pick up the baroclinic zone underneath and deepen down. So even though it may start out as purely a subtropical jet, it's going to deepen and pull in that baroclinic zone.
or what about the invasion from higher latitude? I don't know if this will happen, but the invasion from higher latitude of an upper trough that kind of energizes the southwesterly flow and tags up. This is really one of the questions that's really central to all of these things. How do these two different features of different, latitudinal origin get their act together when they get close to each other? And how do they even get close to each other?
Once they get to a high latitude and the Coriolis effect becomes much stronger, their vertical depth is going to become much more. So that, whereas a subtropical jet may be only a couple hundred millibars deep up real high, as it moves into higher latitude, it's going to deepen down to the ground, just like a polar jet. And then as it does that, it's going to pick up those baroclinic zones and do a frontogenesis job on it. And
So
then it's going to be a polar jet.
Right, so the transition from subtropical to polar jet, it's one entity that just acquires the thermal characteristics. of
Right,
the polar jet.
it just picks up those, it's just like the extratropical transition of a tropical cyclone.
How is it just like that?
Well, a tropical cyclone picks up the baroclinic zone
no, in
and
that
packs it
sense,
in, and
okay.
then it becomes baroclinic, right? And so the subtropical jet picks up the baroclinic zone underneath, and it becomes baroclinic underneath.
Or more deeply baroclinic.
More deeply, well, the lower part becomes baroclinic, the upper part still. And this happens in tropical cyclones too. The upper part stays tropical, the lower part is what becomes baroclinic.
So let's, for the last part, I think of what I want to do is, let's look at the surface map. I want to take a look around the country and see what's going on, where it might be snowing, and then I'll go into this 5U, then I'm all done. So let's start in the northeast. So in the northeast, we have light snow, 37 over 28 at Boston. Interestingly, light rain at Provincetown, 38 over 28. There's no difference in the wind direction, speed, dew point depression. The only difference is you're going across Massachusetts Bay with southeasterly flow or southwesterly flow, landing in Providence. It must be just enough modification to turn it to light rain. But even at Martha's Vineyard in Nantucket, it's 38 over 32 with the same kind of wind direction. That's curious to me. I don't really understand that. It's 37 over 28. Moderate snow north of Hartford, light snow in Albany, and then moderate snow along the lake. Some of it probably lake induced, although it's hard to say, but you got some pretty nice events going on there. And then over the upper peninsula, there's light snow. We have light snow in Wausau today, and we have some light snow in sort of the northern part of the lower peninsula. Even though 33 over 23 and it's raining with a northwesterly wind, how does that happen? There's funny things here that are interesting. So
Also,
that's particularly interesting.
looking at southeast and central Virginia, temperatures approaching 70 degrees.
Oh, yeah.
And these areas tomorrow may be seeing snow, so it's.
Yeah, it's amazing, isn't it? Absolutely amazing. And DC itself is, where is DC? 58? 31? And so that's incredible. Almost 70 across Virginia. So, and it's going to be very different tomorrow. And we're 28 over 12, a lot of low dew points in cold air. And I think we had single digits this morning in the Dakotas. I don't know if we've recovered everywhere above. No, we haven't. Some places are still in the single digits. 9 degrees is that Bismarck or is that
Fargo.
Fargo. Thank you, Molly. It's good to have North Dakota in the audience. So that's Fargo. So that's the only place I think that's still in the single digits in the continental U.S. 9 degrees. No, it's a few in Montana. That's Great Falls, right? Okay, so bitterly cold air, and it's not going to get much better as we're seeing before.
You know, it's quite interesting at this time of the year, we had that snow. When was that? Sunday or Monday or whatever?
Yeah,
Last
Monday,
week.
yeah.
And we never got much above freezing, but it melted right away.
Yeah, I know.
It's just
that's
the
true.
sun.
Yeah,
Shining on the
the sun
ground.
is so strong. I did this on purpose. I didn't shovel the deck. It was 3 inches of snow. I didn't shovel the back deck, and now it's just crusty little bits on the steps. And it really never got warm, as you say. Exactly right. And last place we'll look is right here in Northern California. Moderate rain in several locations north of San Francisco. Not raining at all in the city, it seems, although that's San Jose. San Francisco's on the north side. So it's raining in this vicinity in a lot of places. 52 over 46 rain in Salt Lake City. That's unusually warm, apparently, for such an event. And so this is the place that's under the gun for some heavy rains and probably some mudslides and whatever they also seem to get.
We also just focused briefly on Texas, Arkansas, Louisiana.
Oh, yeah.
So I guess hopefully Ryan may have a chance to say a little bit about, when we get to it, just maybe severe weather that's expected.
Yeah, as we saw on the satellite, there's some nice convective activity across Arkansas, parts of Oklahoma. Thunderstorms reported in the state of Oklahoma, and then moderate rain across western Tennessee and at Little Rock. And then across Texas, temperatures are very warm, dew points are high. They're all in the high 60s, some even 70. Look at these 70 dew points.
That's gross.
69, and then 76 over 61, 80 over 37. So there's an extraordinary dry boundary in there. I don't know if it's got all the characteristics of a Lee-side trough. Sometimes they do.
What's going on in Denver? We're on the
25 over 23.
10th of a mile of visibility.
Yeah, it's obscure
Yeah,
fog.
yeah.
It's,
And 22 over 21, that's freezing rain.
so,
Along the east.
Yeah.
Snow in Fort Collins or somewhere near Fort Collins. Yeah, that's weird, isn't that? What is this, freezing fog or something?
Absolutely.
Wow, that's ugly.
This is the time of year when they get that.
Is that right? No, that's miserable. Yeah, so lots of stuff going on in the central part of the country, brewing anyway, and a lot of the characteristic ingredients, very warm, moist air at the low levels off the Gulf of Mexico, bone dry air off the plateau, and they match up usually with a wind shift, and that wind shift has probably got an orographic origin, so it's quite an interesting setup. All right, let's take a look just for a minute at Vis 5B, just so we can look at this upper front feature that's in our vicinity. So, and we'll take off the cross-section line just for the time being, just so nobody has to see that. I want to point out, thanks. And then I had speed too. I think that's the other, well, one other variable. What's the other one? No. I mean, I have one other line here. I'm not sure what it is. Get the slide down to see. Oh, PV. Yeah. We'll look at all. But this is 500 millibar, 12-hour forecast valid at the same time we were just looking at from last night. So you can see this baroclinic zone rings the southern edge of this deep upper cold flow, and then extends back away from the periphery of that cold flow into the northerly flow of Western Canada. So I'm always interested to see, what the structure of some of these really intense mid-tropospheric baroclinic zones are. And so let's take a look at the cross-section in potential temperature through there. So I try to find a spot where I'm not only in the middle of the coldest air, but also as perpendicular as possible to the isotropes. And this time it turns out to be just about at the trough axis of this fairly sharp upper trough feature as well. So let's tilt it up and take a look at the potential temperature structure. And so these are every 3 degrees Kelvin. The red lines were every 2, so I've decreased the contour interval. But that's a really intense upper baroclinic zone that has elements all the way to the ground. So there's a surface frontal zone associated with this whole complex as well. But the upper frontal part of it is really intense. Let's see, this is 303, 300, 297. So from like 291 to 297 Kelvin, you have a really sharp, steep slope to those isotropes. It's really quite dramatic. Let's take a look at the wind speed max on this. And so here's the wind speeds every 10 meters per second starting at 30. And a nice relationship is the jet core right at the top, on top of the horizontal baroclinicity. And I have 30, 40, 50, 60, 70 meter per second wind speed maximum there, as we saw on our analysis. Extreme horizontal shear at the same place where I have kind of modest vertical stability, but really strong horizontal temperature contrast. So the intersection of geostrophic isotachs and isotropes gives you an idea of what the QGPV would be. And I think the actual isotachs and the theta give you the same thing. So number density of intersection points corresponds to the value of the PV. And so you're going to probably have a nice PV structure with something like that, fairly strongly folded tropopause. So let's see if that's true. We'll put the PV on there. And it does look pretty much like that, doesn't it? Where you have a lot of intersections of the green and purple lines is where you have high values of PV. The smallest value I have here is 1, so I'm doing it every 1. 1, 2, and 3. Characteristically, the 2 PVU isotel cuts right through the jet core because that's where the equator gradient or the low PV edge of the high PV gradient is right in that region in the jet core. So it's a really nice upper structure. But it looks like just a polar front, a polar jet, and not really anything more amalgamated than that. Not surprisingly, we saw that on other pieces of evidence. Let's take the isotachs off, let's take the PV off, And then let's put vertical motion in there. And this is sinking motion only, so every 2.5 centimeters per second, maybe I could have done a different contour interval, but you can see here's the jet core, and there's subsidence on the warm side of the jet, and there's subsidence underneath the jet. It's not quite continuous, but right under the jet core, which serves, of course, to tilt the isotropes that way and increase the horizontal temperature contrast. That tends to be characterized in the horizontal by cold advection in cyclonic shear. If we go back to the top view, we can see whether or not that is the case. And right along the cross section here, we have geostrophic flow is parallel to the green pressure lines, and then the isotropes are in there. So we do, in fact, have pretty strong cold advection and pretty strong cyclonic shear. The wind speeds are greater here than they are to the north. So all of this works out pretty nicely and shows a really nice structure to this. Michael showed us a few weeks ago this tropical tidbits site where you can look at this. I won't bring you there now, but when you do, it gives a cross section roughly along this line at the same time, where the 2 PVU comes all the way down to about 800 millivolts in this upper front. So you can almost smell the ozone. So pretty neat. So that's all I have for this, for what's going on.
Do you want to look at the jet in Pacific?
Oh, yeah, that's right.
You
We're a little
can't,
bit, we can't. We don't have the right domain. That's
Just
too
pull
bad.
down North Pacific one if you want.
Yeah, maybe.
Should we, or you want, yeah, let's do that. Okay, let's do that. We have North Pacific. And I was looking at 0Z, so let's do that, and we'll go to 12 hours ahead forecast. Probably gonna give you something with a 1 in or something. Yeah. Is that it? Yeah, Pacific.
Definitely. Yeah, thanks.
Rats.
It's not the right one. That's the North American one. The one impact, right?
Yeah.
We're just packed.
Right.
Yeah, okay. So it's gonna be a funny angle, but it'll be good to see it. We should be somewhere in here where you can look at this jet. What contour,
73.
70. Let's go something high, yeah. So let's cut it like right here. See what it looks like. Yeah, it's right about the inflection too, so we're just downstream of that. You should see the whole polar pond. Perfect. And then we'll, let's put PV on there too, maybe. Oh, that didn't change.
You want PV?
Yeah, PV, that's what this needs. Let's do one at a time before we don't see the whole thing at once. Yeah. And then move that out of there. So here's the potential temperature cross section associated with this jet feature. We got a low polar tropopause, sort of a next intermediate subtropical tropopause. That's probably the tropical tropopause. I think we're stretching far enough there. So we got a pretty deep variability hanging downward from this subtropical tropopause. It comes all the way down like 700 millibars. It's not maybe as intense as the one further north, but it's on the same water. Then what about wind speeds?
What is,
And I think this goes every 9. The default is some goofy number, so let's get rid of that. do every 10, starting at 30 or something. To, 5,000. So there's our every 30 meters per second, 30, 40, 50, 60, 70, 80, barely 80 meters per second. That's the kind of interesting structure of this jet. It is such an obvious case of one species only, because it's at 300.
It seems to be centered up at 340.
Yeah, it's 340 degree Kelvin, so that's like a subtropical jet, isn't it? And then this other piece down here is not really its own.
That's where it's developing polar jet.
Yeah, yeah.
It's,
So that's interesting. How about the PV? This will give us some idea what that looks like. That looks a little too rounded to really. But it does, strong PV gradient. Once again, the 2 isotel goes right through the jet core. That's always
drawing a polar jet tumor.
Yeah, underneath, yeah. So maybe a little bit less interesting than I hoped, but still interesting. There's something there that is not really your canonical jet structure. It's not the kind that shows up on
It
call.
was from 0 to last night.
Oh, yeah, we were looking at 12. Let's see what it looks like here. Yeah, still be a pretty good place to look at it, yeah. Oh, yeah, that's kind of a little bit different now. The isotachs have kind of moved along downwards along the isotrope, and it's 30, 40, 50, 60, 70. It's not as intense, but the relationships are roughly the same. This is a fairly low or elevated tropopause for a jet core, and that's because the jet core is so high. Yeah, but it's fairly steep. It goes right from the subtropical to the tropical tropopause.
Can we do mixing ratio on this, or some measure of water rate?
Okay, thanks, Greg.
He's got a lot of telecoms. I hear him talking on the phone every day. Oh, yeah, look at that. So the river, that's 5, 6, 7, 8, 9. Well, actually, that's 10 or 11. Maybe I'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's 11. So there's like 10 grams per kilogram right in this chunk right here. And that's out ahead of where the jet is, which is the jet core is right about there, I think.
And effectively just right ahead of the surface front, right?
Yeah, yeah. It's really intense. What I don't know is how anomalously deep is this 1 gram per kilogram. I don't know. But it's a really strong gradient. So, interesting structure. Oh, what's that?
That's a 3D rendering of the same thing. Yeah.
Oh, that's pretty cool. Yeah. Definite connection between the two. Smashing it at the Pacific coast. Nice. So that's all I have.
Okay, I'll say a little bit, and maybe if we have time, we can. Sorry, I've got. We'll start here. Just a quick thing, John was mentioning snowfall chances for one of the plumes for the GEFS, the GEFS ensemble, looking at out to the next, I guess, 192 hours or so. Certainly a non-zero, I guess this is the mean, is, I always get this backwards.
Blue is GFS, black is mean.
Right. So, in anticipation that we're not done with winter and snowfall, perhaps.
Yeah.
You look at these plumes, but and the next shot at a real precipitation perhaps is this is the 6th. That's today. 7th Saturday, 8th Sunday, sometime Sunday night into Monday, perhaps the next opportunity for some snowfall. All right, man. Non-zero, but again, this is, well, if we go back up to the top, go to pivotal, and go to home first. Just look at a couple of things. So this just shows the current hazards for across the country. I guess with some really strong winds and very dry air and low dew points, there's a fire hazard out west. They've got the so-called red flag warning for the south central part, or the southern Texas and western Texas, that's the area all the way out to southern New Mexico. Chance for a freeze across northern Texas all the way to Missouri and in western Kentucky, and then some chances for winter weather over Kentucky, western Kentucky, eastern Kentucky, and West Virginia. So winter's not over, and then watches and warnings or advisories that are up in this region.
It's all on the south side of the upper front axis.
Yeah, all just right, you know, kind of brackets it, and then this is perhaps going to be lake effect or lake enhanced type of activity with the upper trough. And finally, chance for significant rain, flood watch over California. We could go to CPC site just for looking at the hazards, click on that. For temperatures, 6 to 10 day temperatures. Again, likelihood that we're going to stay chilly in the northern, western part of the United States, or the chilly in the south central United States, warming up. And then we go to 8 to 14 days. That pattern doesn't really change too much.
No.
We still likelihood of our staying relatively warm. So the heat or the warmth perhaps spreading eventually to the eastern part of the United States. And for precip, staying somewhat wet, below normal wet. Maybe there's that chance for snow, and then that persists also into the early part, next 2 weeks or so out. Not going to help much for the folks down in Texas and New Mexico with potential for drought fires. The next thing, just very quickly, this is go to SPC. And okay, so there's the fire concern right here for fire weather. This is critical elevated risk for fire weather outlook. But the other portion of this, if we go to the more this enhanced risk for severe weather over eastern Texas and northern Louisiana. And I haven't looked much at this. I don't know if you had a chance, Ryan. Are there particular elements that you've seen in the maps today that would
we talked a little bit about this in class yesterday.
Do you want to come up and
Sure, yeah.
see a little bit of them?
You mentioned that the radar loop, that traditional radar loop. Still have it up.
You want to down the south?
Yeah. What is on the national one?
Nationals right
Yeah. So, this is actually a pretty fantastic example of just continuous isentropic lift over this front that's kind of situated across Oklahoma and Arkansas. So I saw a couple of flash flood warnings there. So eventually what looks like it's going to happen is there's this front here and there's this kind of continuous convection being forced over the frontal boundary, the frontal surface. And then later today, as out in the warm sector here, as this becomes more unstable, then there's going to be a cold pool that sort of congeals and emerges from this and slides to the southeast, and convection will be basically continually forced on that into the warm sector here. So I think the biggest threat is going to be for some sort of organized NCS or squall line system that sort of congeals and comes out of this massive precip and new convection over the next few hours. So exactly how that is going to unfold, I think there's still uncertainty with that, looking at a lot of the high-res model guidance, since it's kind of a function of how this convection is initially represented in the model. There's a decent amount of uncertainty.
So how does you said that this cold pool can form in the region where you already have this existing convection on the cold side of this existing baroclinic zone? What changes it from staying stationary then eventually moving southward?
I agree. That's kind of an unclear process to me. So right now it's all basically north of the stationary boundary. This could involve maybe new convection developing here along the boundary in the area where it's most unstable. So this region down here, if you look at basically the low-level shear vectors, they're oriented in such a way that you expect new convection to develop down in this region in northern Louisiana, basically perpendicular to the orientation of the low-level shear vectors. And so this would be favored in this region, whereas this is all sort of driven by an overnight low-level jet and just being continually forced elevated convection. So once there's the development of this surface-based convection, maybe along this edge, where there's this favorable orientation of the low-level shear, then that I think could be kind of the instigator to start the development of this of a purely surface-based strong cold pool driven by convection and then propagate to the southeast. That's how, in my mind, this might play out. So they have, I think if you go back to the risk and enhanced risk, I think it's
driven primarily by that expectation for some sort of organized MCS, conductive outlook there. And then, yeah, we get into the, I think there's probably this discussion. There could be some in the warm sector. I think there's a pretty strong cap of the warm sector right now. So as that dissipates, there could be some isolated convection with large hail and maybe some tornadoes with that. But then it's upscale. These frontal storms are upscale into some sort of squall line that will eventually surge southeast. So the isolated convection will be potentially able to produce hail and tornadoes, and then more of a wind and maybe embedded tornado, mesovortex tornado threat as if that system becomes mature enough to support those types of hazards. But yeah, it's pretty neat to see this continuous forcing of convection in this region. It's almost stationary.
Yeah.
Pretty nice example of
We think the key thing is just how the models represent that and the eventual.
Yeah, I mean, there's still, just looking at a lot of the convection models, there's still a decent number of amount of uncertainty in terms of what kind of emerges from that, especially if there's been convection out in the warm sector too. Mm-hmm. That plays a role, and what evolves up here. There's convection in Louisiana, maybe that ends up growing upscale. So it looks like this kind of area in this region here is up there, the large spread area. Again, because of that kind of that favorable, so basically a favorable global shear. So any sort of upscale growth that happens, you'll get a propagation to the south.
Well, thank you.
Thanks.
Surface, 12 hours, GIFS, 12 hours, first, and then preset type and rate. We'll just quick through relatively quickly. So here's the 12-hour forecast for 0Z this evening, and luminous region heavy precipitation. This is obviously accumulated over the last, I guess, 3 to 6 hours here. So this is some of the convector precipitation, but sort of, or maybe that's the emergence of this new convective blow-up that's expected to occur. But for us, it's like strong cold advection, sort of brisk late afternoon, early evening with northerly winds, and the precipitation we saw on the radar continuing over the northeastern part of the United States, maybe becoming more just liquid precip as opposed to frozen precipitation in eastern Illinois. And then back over the Rockies out in Colorado, with this upslope flow, some snow, and snow continuing. And finally, the western part of the United States, there's our big rain event that's beginning to start out. Let's go ahead 12 hours to tomorrow morning. Tomorrow morning. That front is pressed further to the south, and the liquid precipitation, the rainfall that was the east, has now become snow. So you can see those regions, those places today, just southwest of DC, that were in the 70s or approaching 70 degrees by tomorrow morning. At least this, believe explicitly this forecast. Looks like precip type is most likely to be snow from DC and Baltimore southward.
There's cherry blossoms out.
Yeah.
Yeah, that was just maximized yesterday. I think it was peaked yesterday. Right? So that's going to be maybe an uncomfortable thing, but this is not going to be accumulate much. The surfaces are going to be extremely warm. Yeah, they did get snow about a week ago or so, and it accumulated, but this is going to be pretty much grassy areas at the beginning of the accumulation.
That'll be the best news of the week for Scott Pruitt.
Right. Something else to talk about?
Yeah, well, it'll be cold when it should be warm, and he'll say that means there's no global warming. He'll feel vindicated.
Yeah. It is fun. But the other interesting thing about this was initially this was supposed to be just a frontal passage, things clear up. But the models have been indicating in the last couple of runs that it may be emerging from some interaction with the convection that's over the southeastern part of the United States. A frontal wave is expected to develop and then move northeastward along this. And so they're actually going to get sort of 2 rounds of precipitation with this. For us, just to, again, I don't want to forget that we're here on the Midwest, cold advection occurring, and it looks like a nice day tomorrow with just very chilly day tomorrow. Another 12 hours, please. Here's that second wave developing as precipitation. So from Roanoke and parts of southwestern Virginia, this wave begins to develop. with elevation, they're gonna get certainly snow, but that snow being moved back into the DC area tomorrow evening. I don't think any Rockies games or Orioles playing over the weekend at home, but that would be just not a pleasant day.
We're gonna have salmon out here in about 2 weeks too, so for 1 week. I'll get to hear him say it's gonna be a good week for complaints to his weather blog this week, so it'll be
I
great
think
to hear.
people in that blog are often more excited about the snow
Yeah,
than disappointed with it. But again, for us, this is tomorrow evening, again, just end of a chilly day, the winds will be diminishing with that high just about to crest on top of this. Another 12 hours for these people. And finally, that storm exits the east coast. And we're still cold, but the nice ridge overs tomorrow morning, very light winds. So tonight, tomorrow night should probably be the colder of the 2 nights, I imagine, for us. And snow beginning to break out in the Dakotas. So warmer temps beginning to set up. The atmospheric river was actually relatively short-lived, right? The rain was pushed to a much higher latitude, and it's cleared out California.
yeah, by Sunday afternoon, it's all over.
It's just amazing, still getting freezing precipitation in Kansas, approaching the second week in April. All right, so Sunday night, things begin to get interesting. So it's 60 hours. Good area of snow in a region of sort of localized warm advection, beginning to spread closer to us. Again, the southern part of the United States is nice and warm, but you're watching this little wave develop over South Dakota. Another 12 hours, 72 hours for Monday morning. But if this pans out, Monday morning could be a light snow in the air, maybe some light accumulations. I heard awesome from someone.
Yeah.
But,
It's gonna be a great day.
bring it on. Yeah, just bring it on.
Melissa's gonna defend your dissertation, it's gonna be snowing. What could be better than that?
It's really 3 weeks later, we're getting snow. I think it's even better. But really nice. You can see a thermal wave in the fitness field. Nice, cyclone swim on the tip of it, the apex of it. But from across down the Madison, it's like a little bit of snow. And again, even more snow back in the middle Atlantic.
Yeah, see that structure there in north central Iowa, that means it's gonna snow all day here on Monday.
Right.
Lightly, but nonetheless, it'll snow.
Let's go to 78 hours before that. There it is.
Yeah.
Really slow moving pattern. And I imagine, let's just also look at 500 millibars at this time. And what's cluing you in on the fact that it's going to be a long-lived event?
Just because this thing looks like it's gonna be moving along that Barrett Peninsula with no substantial wave. I would guess the wave is weak.
Yeah, and then there you see it. You can also kind of get a hint of it in the fitness field, but
Yeah,
500 millibars, there's not much curvature at all with this. It's really just a surface edge wave.
yeah. And
Probably stronger 850.
I bet that's right. And so that structure made me think that. I didn't put it in those words, but that's exactly what I was thinking. Kind of a surface.
Yeah.
Crosby wave.
Oh, okay. So let's go to 850 millibar temperature. Yeah, but
It's like, is this a hole? And no, it's not a hole. And pivotal.
yeah, nice little thermal wave, thermal ridge just south of, in southeastern ridge. The thermal ridge axis is just along the Illinois-Iowa border. A nice cyclonic circulation, and again, the propagation of this being right along the Barrett Peninsula of the surface. Right. And that's strong. Just because the other factor here is if you're looking at sort of the creation of this thermal ridge downstream is going to favor Q-vector convergence in this region.
Yeah.
Right here. So the long isotropic part of the Q-vector. Let's go ahead. Another 6 hours. Let's go through slowly. As John had predicted, you had a very slow motion of this wave as it heads to the east, but also it looks like the thermal ridge is losing some of its integrity in terms of overall structure.
Yeah, and consistent with that, the seeable pressure rises, so there's not as much ascent as there used to be.
So this is a weakening wave of sorts. We'll go to 90 hours and we'll pick up the pace with the maps. So it slowly just edges out, and the wave, you can see the amplitude of this thermal ridge is even weaker at this point.
Yeah,
This is really being fallen apart. 96 hours. Still hanging on over Michigan and Detroit, getting some snowfall. But we're going to get chilly again with a northerly wind as this wave departs. Let's go 120, please. And by that time, we don't see much left at all. But warm advection finally starting. This is finally the nice beginnings of a recovery, I guess, by Wednesday of next week. And right now, this is more towel. Liquid precip, no snow to worry about. But if we just advance to 168, and we'll go through this quickly, so this will be Weather Watch next Friday.
Oh, yeah.
Nice, nice mid-continent storm, nice strong warm advection. Gets it still dry and not much is actually broken out in the plains yet, but
I don't think there's any preset that breaks out just because of lack of good low level moisture and,
Yeah, it's amazing, isn't it? That stays all on the northern edge of the storm.
right, but the high plains blizzard, I guess.
Yeah.
That's probably what's gonna happen.
Wow.
It looks worse than it is because of the 2 millibar contour.
It's still 982.
Yeah, can't get around that. And if we just look back at a couple of runs, go to the 0-0 run, please, for a second. But this is better than forecast, or some version of it.
Yep.
Yeah.
A little bit further to the northwest, a little bit more intense.
Well, what a difference along the trailing Gulf Road.
a lot more
Yeah.
warm sector.
Yeah.
We're there, but shifting locations. That's been consistent with forecast, broadly speaking, going back into Thursday. That's when we kind of lose it.
There's plenty of cold air back there when this thing goes by, though. Oh, yeah.
Okay. And we go ahead, snow's not over yet. So here's at 192, we're still in the warm sector, but you know what's gonna happen. Go ahead, there we go. More snow as we get to
Next Sunday.
April 15th.
Tax
Taxing to everyone. And then,
You will be?
I don't really have much more to say. We can flip through a few more beyond this, but it looks like finally we get out of winter. Except, I do have one thing I want to add. I'll be gone from the 13th to the 20th, but if we go to the CFS, I think there's still a chance for me to see some snow. Go to 480 hours, there's a sneaky feeling that there'll be something.
That's only 20 days.
Yeah.
Yeah, okay.
20 days, yeah. Hey, so,
Wow. Snow on the 26th of April.
if that were to verify, which of course it's not.
That's awesome.
I think bring it on. That's like I always say about snow. Anyway, well, thank you, John, for a really great discussion, and Ryan as well for giving us an update on the severe weather, the likely outcomes of that, and Pete for driving, and everyone for coming, and have a wonderful weekend.
All right.
Yeah, nice job.
Oh, thanks. Ready for lunch?
Yeah.
Thanks, Pete. Thanks, Ryan.
Good luck.
26th of April is going to snow again. What if it does? Wouldn't that be unbelievable?
Lorenz is rolling over in his grave.
Yeah.
480 miles per hour.
Sure. What did you guys do? We didn't even listen 55 years ago.